Hi everyone and welcome to today's lesson. Today's lesson is on energy stores and systems. It's one of those topics as part of the physics GCSE specification, and it covers quite a big range, okay? So you'll be, if you're doing the AQA spec or the OCR spec or even the EdXL specification, you will be expected to know about energy stores and systems. So if you are writing this down, I suggest that you write down the title and the key words. And if you want to write down learning objectives, you're more than welcome, because it might help with your revision. Okay. If you're not writing things down, or if you're not in a place where you can write things down, you just wanted to listen, that's absolutely fine as well. There's lots of activities that you can do. So today we're going to be recalling the 8 different energy stores, okay, and we're going to be understanding that energy is the ability of a system to do work. There aren't many past paper questions on this, but we'll have a go at a couple, okay. Today's keywords are energy, joules, kinetic, gravitational and elastic. So hopefully this is going to kind of bring back some of that information about energy stores that you might have done in year 7 or year 8. So before we get started, I want you to think of the different ways energy can be stored and listen to my language. I'm not saying types of energy, okay, because we're not talking about types of energy anymore. A few years ago, we did talk about types of energy, but actually the GCSE has changed slightly and we've got to be careful of our language. Energy is just energy. It's the ability to do work, okay? Or if you're particularly physicsy, you can say it's power times time. But it's energy is just energy by itself, but it can be stored in different ways. So what I want you to do is have a think about the different ways that it can be stored. If you need a little bit of a reminder, I can give you a hint by saying that the key words might help, okay? So kinetic, gravitational, elastic, they might help bringing back some of the different ways that energy can be stored. So let's go straight into it. All right, we need to remember the different ways that energy can be stored. And for this, we might need something like what I've got on the screen. So this is a mnemonic, okay? It's basically just a saying that helps us remember. You know how Richard of York gave battle in vain might help you remember all the different colours in a prism, in white light, which is broken into by a prism. So this is a specific mnemonic for energy stores. Yeah, England needs good kings to make chocolate eggs. Okay, now you can make up your own mnemonic, and of course these can go in any order you want, but this is just one that I think is quite easy to remember. England needs good kings to make chocolate eggs. What do these words stand for? Well, they stand for the energy stores. So we've got elastic potential, nuclear, gravitational potential, kinetic, thermal, magnetic, chemical and electrostatic. Okay, England needs good kings to make chocolate eggs. All right, so what I'm going to do for the next little while is I am going to just be talking through some of these with examples. Okay, if you want to take notes, you're more than welcome. It's probably a good idea. If you just want to listen, that's okay as well. So it will be a few minutes of me just talking, but we're going to have a go at a past paper question, and we're also going to have a go at another activity after that. So make sure you're paying attention, okay, just for a couple of minutes. Now, if you want to take more of an active role in this session, I'm going to tell you that these 8 pictures, they show a specific energy store. Okay, now they might actually show more than one. For example, this person, you might be thinking, well, okay, she's moving, but she's also a person. She's also off the ground a little bit. There's lots of different energy stores, but the main one, that's what I'm going for. So if you kind of want to take a bit of an active role in this session, what you can do is you can pause this video and you can see if you can guess, okay, what each of these pictures represents in terms of an energy store. For example, maybe this one represents elastic potential energy. Okay, so like I said, if you want to, you can pause this video and have a go at guessing before I go through them. All right, so I'm going to go through them now. What I will do is I will include one of these pictures in my explanations. For example, elastic potential, okay? So this is obviously the picture that I used in here. Like I said, what I'll do is when I go through them, I'll use the image on the left-hand side if you did have a go at the previous activities. So, guys, elastic potential please don't think too much that it's just about elastic, okay, like elastic bands, or if you've got a hairband that's got elastic in it. It's not just actually that, okay? It's not actually just saying things that are made of elastic. It's anything that has the potential to go back to its original shape. All right, if you crushed a Coke can, for example, you'd be giving it elastic potential energy because it wants to now go back to its original shape. You might leave it and it might start to kind of go back to its original shape. So when you squash something, if you squash a piece of paper, if you squash, if you squash a piece of plastic, if you squash something, if it's made of a certain material, you give it elastic potential energy. Okay, an elastic potential store of energy because it wants to go back to its original set shape. So this is quite a good one. Maybe there's a couple of things happening here. I was looking at this ball, okay? So now you have given this ball elastic potential energy because it's squished, it wants to go back to its original shape. Maybe you've given this footballer elastic potential energy because his face is now squished and it wants to go back to its original shape. All right, next one, nuclear. Really well done if you spotted that with the sun. There's only a few examples of where we're going to be using nuclear store of energy. The sun is a huge one, okay? It's actually nuclear fusion between two hydrogen atoms that are fusing together. We also might find it in a nuclear power station, all right? Actually, that's part of the physics specification, and then you'll have another lesson on that. Or, of course, if you've heard of nuclear bombs, that is another example of where you might find a nuclear energy store. It's really only those three, to be honest, on this planet at the moment. Okay, so these are some of the examples. Gravitational potential is one that they use a lot in GCSE questions, okay? So, especially with equations, okay, and calculations. So essentially, it's anything that has the potential to fall down. All right, so right now, if you're sitting down like I am, okay, I'm on my chair. I don't have very much gravitational potential energy. If I was sat on the floor, I would have no gravitational potential energy. If I fell down, I'd fall on the floor. Okay, so if I'm sat on the floor, I would have no gravitational potential energy. If I stand up, I now have some gravitational potential energy because I have the potential to fall down, okay? If I am holding, say for example, I have a calculator here. If I'm holding this calculator, it has gravitational potential energy, all right? If I hold it up here, it has more gravitational potential energy. So for example, this lady in the picture, she will have more gravitational potential energy than this gentleman here. All right, because she's got further to fall, she has more gravitational potential energy. These guys on this roller coaster have loads of gravitational potential energy, right, which will decrease as they go down. So anything that has the potential to fall down, okay, or anything that has the potential for gravity to have an effect on it, has got gravitational potential energy. Kinetic is a nice, easy one. Really well done if you spotted that this one was kinetic, because I was trying to show something moving. Kinetic just means movement, okay? Anything moving has that kind of store of energy. Right now, I'm moving. I have kinetic store of energy. You guys have kinetic store of energy. Even if you're not moving, your heart's beating, your lungs, expanding. We're moving constantly, okay? So anything that's moving has kinetic energy. Thermal, this is a nice easy one, okay? So thermal, again, something can have a thermal store of energy. Your phone, for example, when it gets very hot, has a large store of thermal energy. A hot bath, or of course, like a fire that has lots of thermal energy. Magnetic, quite simple, I think, to understand. Anything that, for example, a magnet would have a very strong magnetic store of energy. Of course, I just want to throw this out there that the Earth is a giant magnet, okay? We have a North Pole and a South Pole because we are a giant magnet. And again, you might be thinking, oh, they've got that the wrong way around, right? Because you're thinking, oh, well, they've put South at the top, how embarrassing. That's actually not quite true. That image is correct, but I think that's for another day, okay, when we look at magnetism later on. So this is a nice and easy one. Your phone actually is slightly magnetic because the battery has a magnet in it. So sometimes if you've taken your phone out of your bag and say if you've got something stuck to it, maybe if you've got a hair clip stuck to it, it's because your phone is magnetic, so it has a magnetic store of energy. chemical, people get a little bit confused because, you know, it's really about any kind of reaction that is taking place. So I've put an image of a person here because I have a huge store of chemical energy. You have a huge store of chemical energy. All of your cells right now are respiring. They're making proteins. There's loads and loads of chemical reactions taking place in us. Also, maybe you've just eaten, okay? Maybe you had breakfast, maybe you had lunch, maybe you even had dinner. There's a huge chemical store of energy in your system. So in exam questions, they might look at batteries, they might look at cars, actually, that's because of the fuel in cars. They might look at people, okay? So yes, I have a kinetic energy store, but I also have a massive chemical energy store. All right, if I stand up, I have a gravitational potential energy store as well. There's lots of different energy stores that I have. Electrostatic. Okay, so we're almost there. So electrostatic is quite specific. It's essentially, if you think of anything where you might get a bit of electric shock, all right, not from current in terms of electricity, but maybe if you're jumping on the trampoline, you know, you wouldn't want to pick this dog up because you might get a bit of electric shock. There's lots of electrostatic energy. All right, so this is an example. These three are really good examples of electrostatic energy stores. Maybe if you've used the Van de Graaff generator at school, where you put your hand on that dome, the Van de Graaff, that it has a really big electrostatic energy store. Right, enough of me talking. Let's have a go at a practice question. Again, there's not many to use because it's quite a new idea, this whole idea of stores. But let's have a go at this one together. So it says some pupils go in a log car. So go in a log car on a theme park ride. The drawing below shows the ride. Okay, so the letters A, B, C, D, E, and F show different points along the track. The car starts from A over here and travels to F, okay, where it stops. At E, the car enters a trench filled with water. So it goes down, up, down into the water. All right, so just have a look at that image. Let's have a look at the questions. So this is probably out 4 marks because there's 4 spaces. At which 2 points does the car have no kinetic energy? We'll look back at the image in a second. At which point does it have the most gravitational potential? And at which point does it have some kinetic and the least gravitational potential? All right, so let's go back to that. And of course, if you need to pause this video so you can kind of flick between the 2 slides, that's absolutely fine. Okay, so the first question was, at which 2 points does the car have no kinetic energy? None. Kinetic is about movement. Have a go. The next question was about most gravitational potential energy. And the third question was, at which point does the car have some kinetic and the least gravitational potential, but some kinetic? So have a go, please. All right, if you, like I said, if you've got a pad or paper and a pen, please have a go at writing it down. If you're just listening, you can do it in your head. Okay, so if you haven't already had a go, then quickly pause this because I'm about to give away the answers. All right, so really well done if you did A and F for no kinetic energy. Okay, most gravitational was A, and some kinetic, but the least gravitational is E. Let's just quickly show you what I mean by that. You know, A and F, they are not moving at all. They are not moving at all, so that has to have no kinetic. At A, they have the most gravitational potential. Of course they do, it's the highest, all right? And when it has some kinetic, but very little gravitational potential, I would say here, because it's on the ground, but it's still moving. So really, really well done if you got this correct. Give yourself lots of ticks. All right, very quickly, I want to finish on this idea of an energy system. Now, people get really confused, but I promise you a system is actually really easy to understand. Okay, energy is stored in different ways in energy systems. Okay, so for example, a car contains many different objects. Okay, a car might contain a battery, it will contain petrol or diesel, it can contain lots of different things. Okay, so it contains lots of different systems. Essentially, it's just objects. Okay, it is just a system is a fancy way of saying an object almost. All right, so we can say the system of the car battery has, you know, a store of chemical energy. We can say the system of the car fuel has, again, chemical energy, or the battery might have magnetic energy store as well. Okay, so it's just a fancy way of saying, you know, objects. So maybe let's take me, for example. The system of an organism, or the system of a human organism, will have lots of other systems. Okay, the system of the heart, it will have maybe the system of my muscles. Okay, and again, that will have different energy stores. So the whole car, let's go back to the car, is also a system made up of lots of objects. When it moves, it's got a kinetic energy store, okay, and it's also got thermal energy. So we can say the whole car is a system itself. Or we can say that inside the system of the fuel, the system of the battery, the system of, I'm trying to think of other things, the brake system, all right, that might have thermal energy store. So please don't get too confused when they use the term system in a past paper question. I did also very quickly want to talk about the way energy is transferred. It hasn't come up in a past paper question yet, but technically it's part of your specification. So this will only take 2 minutes. When a system changes, the way it's stored also changes. Energy is transferred from one store to a different store. Okay, now that sounds like it's really complicated, but it's not, I promise. So for example, say if you're going from a power station over here, yeah, and we're going to boil a kettle using the energy we're using from the power station. Okay, the system of the power station might have mainly a chemical energy store because they're burning oil. The system of the kettle might have the main energy store as thermal. Okay, and obviously energy has been transferred from this store to this store. Right, because energy cannot be created or destroyed, it can be transferred from one store to another, as I've just said. So let's look at the 4 different ways that energy can be transferred. All right, there are 4 different ways: heating, electrical, mechanical, or radiation. So energy can go from one store to another via heating, via electrical, okay, like in a current, okay, in a wire, mechanical, which essentially is just movement, or radiation. Right, so stick with this. I know there's lots of different words, there's lots of different things that you need to learn, but you need to know that there's 8 different energy stores and there's 4 different ways that energy can be transferred from one store to another. All right, let's just have a quick example. Again, if I'm going too fast, that's absolutely fine. Please just pause the video and go over anything, especially if you're writing things down. Right, let's work this out. When the spring is squashed, energy is going from us. So if I'm squashing a spring, I'm using some of my power, I'm using the chemical store. Okay, so I've got a huge chemical energy store because I respire and because I've just eaten lunch, let's say. I'm using all that energy to squash a spring. So it's going from my chemical store to elastic potential energy that is now stored in the spring. Now, how has it gone from chemical to elastic potential? Think about the different pathways. There's 4 different ones. What would you say? How has it gone from chemical to elastic potential? It's going through a mechanical pathway, right? Because I'm physically doing it. Something is physically moving. All right, I haven't heated up the spring, which has caused it to be squashed. It's a mechanical pathway. All right, so it's gone through a mechanical pathway to increase the store of elastic potential energy in the spring. Just to finish off then, so really well done for listening for that. It was a lot of me talking, but it's just a lot of theory, unfortunately, that you just need to kind of learn, and you need to learn the examples as well. So to finish off, all right, I think it's a really good idea either to do this written down or to do this in your head. I want you to sort these into 2 different piles, okay? Is it an energy store or is it an energy transfer pathway? So is it basically a way that energy can be transferred from one to another? So for example, mechanical, was that a store? Think of the mnemonic, was that a store or was that a pathway? I want you to pause the video now and have a go just to finish off this session, just to bring everything we've done together. I want you to, like I say, write all of these words or phrases either in energy store or if it's an energy transfer pathway. Okay, pause the video and have a go at that now. If you haven't quite finished, make sure you pause because I'm going to give away the answers. Let's just check that you got it right to finish off. Here are the answers. All right, so you've got your 4 energy transfer pathways: electrical, heating, mechanical, radiation, and you've got some of the energy stores here. So really, really well done if you did that. If you did that without looking at your notes, that's really impressive. That's fantastic. Okay, I hope that was clear. I hope you enjoyed the session and you took something away from it. If ever you need to obviously re-watch anything that I've explained, please do so and take this opportunity to do so so you've really understood learning objectives. Okay, thank you very much.